Hello guys, as you guys requested, in this video I'll present to you guys the solution for MATS2108, the exam that came in 2020/2021 first semester. So the first question says, question number 1, the A part says, find the number of ways in which the letters of the word standard standards can be arranged. To do so, we need to count how many letters are here, or how many letters belong to this word. That is the number of letters. The number of letters is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 letters there. And then we equally need to know how many of the letters repeat themselves. That is, we have repeated letters. Repeated letters are this S and this S repeat 2 times. A and A repeat 2 times also. And which one again? Z. Z and Z repeat 2 times. Therefore, the total number of ways would be this factorial divided by all of these repetitions. That is the total number of arrangements equals 9 factorial divided by these ones. That is 2 factorial, 2 factorial, 2 factorial. If we simplify all of this, it gives us a total of 45,360 arrangements, which completes the solution for the first part of question number 1. Then, the second part, B, was still on number 1. The B part says, find the number of ways in which a committee of 6 members can be selected from 6 males and 4 females parliamentarians, given that it must contain at least 3 female parliamentarians. Alright, we want a committee of 6 members from what? 6 male and 4 females. This question has a condition. The condition is that we have to select some people from the males and some people from the females, so that the total number of selections should be 6 per selection. And then the condition is that each selection must have at least 3 females, meaning that the lowest number of females in each selection should be 3. So we must attach the condition at least 3 females. If we apply this condition, it is going to give us the various possibilities that each arrangement or each selection is going to have. The possibilities will be, we have the males, or let me say the females and the males. Now, there must be at least 3 females, which means that that's the lowest number, 3. And if we already select 3 females, then we need 3 males to complete the 6 members. If not, there can be 4 females. And if there are 4 females, then to complete the 6 members, we need 2 males. Then, if there are 5 females, we are going to need just 1 male. But we will not consider this possibility because the number of females, the total number of females is just 4. It's not up to 5. So this possibility does not exist. So we have only these two possibilities, which means either this or this. So we work with this. We are going to have that the total number of selections is equal to, we are going to select 3 females out of how many? Out of 4. In 4 combination 3 ways, and 3 males and means multiplication, and 3 males out of 6. So we have it this way. Or we select 4 females out of 4 and 2 males out of 6. The 6 combination 2 ways. This is going to give us 95 ways. That for question number 2. Question number 2 says that the A part, first of all, find the range of values of x for which the expansion 3 minus 2x to the power half is valid. We know that what the expansion of a plus x to the power n is valid if and only if what? The magnitude of x divided by a is less than 1. So we are applying that here. Here our a is 3 and our x is negative 2x. This follows that the range we are looking for is the set of all x for which this, the magnitude of negative 2x divided by 3 is less than 1. If we simplify this, it gives us x for which this is 2x, negative 1 is less than 2x on 3 less than 1. If we simplify further, it gives us, we multiply all through by 3 and then divide by 2. This is negative 3 is less than 2x less than 3. And then finally, we can divide all through by these 2. It gives us negative 3 on 2 is less than x less than 3 on 2. So this is the range of values of x for which that expansion is valid. Then number 2b. Number 2b says find the term independent of x in the expansion of x squared minus 1 on 2x to the power 6. Find the term independent of x. Here we are applying the binomial theorem. Still, from this, we know that a plus x to the power n, by the binomial theorem, it is what? The sum of n combination r, a to the power n minus r, x to the power r. Again, in this case, our a is this one, and our x is all of this. So, using the general term, since the question has asked us not to expand, but to find the term independent of x, we use the general term. The general term is n combination r, a to the power n minus r, x to the power r. With this, we have n, our n in this case is the power of this binomial, which is 6. So we have 6 combination r. Our a is this, that is x squared to the power n 6 minus r, and then our x is all of this, which is negative half x to the power r. We now simplify this. It gives us x from indices. We multiply these two powers so that we have 2 times 6. 2 times 6 gives us 12. 2 times 12 gives us minus 2r. And then still from indices, we can write this as negative 1 on 2 times 1 on x to the power r. This gives us 6 combination r. x to the power 12 minus 2r. Then, still from indices, we can separate these two. That means we have negative 1 and 2 to the power r times 1 on x to the power r. This gives us 6 combination r, x, with negative r to the power r, x to the power 12 minus 2r, x to the power negative r, which is equal to 6 to the power 6 combination r, negative half to the power r, x to the power, since we are adding, multiplying two numbers having the same base, we add their powers. So we are adding this and this. It gives us 12 minus 3r. Simplify the general term in the binomial expansion of that binomial. This is what it gives us. But we want the term independent of x. The term independent of x is this term. This is the term independent of x. Independent of x means that this x should be r. So if we take out the x, this is going to give us our term independent of x. But you notice that it has r, which is an unknown. We don't really know the value of r. So to find the value of r, we equate the power of this man. We equate this power to 0 and obtain that value of r. That is for the term independent of x, this power should be 0 so that we can obtain the value of r, which we are going to substitute here. This is going to give us r as 4. So substituting there, we are saying that therefore the term independent of x is equal to 6 combination 4 negative half to the power 4. Simplifying this gives us, simplifying this gives us 15 on 16 as the term independent of x, which completes the solution for question number 2. For question number 3 says that the relationship between two variables x and y is as shown in the table below. This is the table. The A part says, determine the least square regression line of y on x. The least square regression line. We have the A part wants us to find the least square regression line. And we know that that least square regression line for y on x is y minus y bar equal to the covariance of x and y divided by the variance of x into x minus x bar. So this is the formula or the equation we are looking for. And what do we need? We need x bar, y bar, this and this. So we find it. But x bar is equal to, you know that x bar is equal to the sum of all x divided by n. So we add all these numbers and divide by the total of numbers that are there. That is, we have 15 plus 16 plus 80 plus 20 plus 25 plus 10, 27 plus 30 plus 32 plus 35 plus 40 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 of them. So if we do that division correctly, it gives us 129 divided by 5. Then for y bar is the same thing. sum of y on n. That is, we have y is 9 plus 3 plus 8 plus 10 plus 1 plus 5 plus 7 plus 2 plus 6 plus 4 divided by 10. Also, simplify this one gives us 11 on 2. Then, to find the variance of x, we know that the variance of x is defined as what? The sum of x squared divided by n minus x bar squared. So this means that we need to square x first and then add everything. So I'm going to square it on this table. I'm going to square it here, x squared. If we square x, we are going to have 225, 256, 324, 400, 625, 729, 900, 1024, 1225, 1600. And if we add everything, it gives us 7,308. All this divided by n, then minus x bar squared, which was 129 on 5 squared. We simplify that fraction, it gives us 1,629 divided by 25 as the variance of x. Then, for the covariance, of x and y, we know that it is the sum of xy on n minus xy bar. So again, we find this xy. Carry back to our table, we can determine that xy simply means we multiply these two. If we multiply, it gives us 135. The other one gives us 48. The other one gives us 144. The other one gives us 200. The next one gives us 25. The next one gives us 135. The next one gives us 210. The next one gives us 64. The next one gives us 210. And the last one gives us 160. We now add everything. It gives us, it gives us 1,331 divided by 10 minus x bar. X bar was 129 on 5, and then this other one is 11 on 2. We simplify all of this correctly, it gives us negative 4 on 5. So we now have everything that we need to find that regression graph. But before we do so, let's first of all find the quotient of this division. That means the covariance divided by the variance of x is equal to what? We know that this is the covariance, which is negative 4.5 divided by the variance. The variance is 1629 divided by 25. So we simplify this correctly, it gives us negative 220 on 1629. Therefore, the line is y minus y bar. Y bar, so the y bar was 11 on 2, which is equal to this guy, negative 220 on 1629. 129 into x minus x bar 129 on 5. This is our regression now. But if we like, we can put it in gradient intercept form as y is equal to -220 on 1629x plus 29,271 divided by 3258. So that is our regression line. The next part line then says that we should calculate the product moment correlation for the data. The product moment correlation for the data, that is the B part, we have that the product moment correlation coefficient is what? Is R equal to what? The covariance of x and y divided by the standard deviation. That's the formula. So we already have this one. We have this one, but we don't have this one. So we need to find that one. To do so, we have that but the covariance of x and y is equal to negative this and the variance of xx is equal to, we found already, we found the variance, it was 1629 divided by 25. Alright. Also, if we calculate this, that the variance of y, it should give us 161 on 20. Now applying the formula, r is equal to, we have the standard deviation, which is -4, that's -4 on 5 divided by the square root of this times this, that is 1629 on 25 times 161 on 20. If we simplify it correctly, we get approximately -0.384 right to 3 decimal places, which also completes the solution for question number 3. Question number 4a. It says that two events A and B are such that the probability of A is 1 on 3, the probability of B is 2 on 9, and the probability of A given B is 1 on 2. Fine. Question number 4, but A says two events A and B are such that the probability of A is this, the probability of B is this, and the probability of A given B is that. Find Roman 1, the probability of A intersection B. Roman 2, the probability of A union B. And Roman 3, the conditional probability of B and A. Like that. To solve this, to find the first one, Roman 1, that's the probability of A intersection B. To find it, we are going to use this result, the formula for this first of all. Because we know that the probability of A given B is equal to, is defined as the probability of A intersection So you see that from this formula we can now make A intersection B the subject and have the expected result. So making A intersection B the subject, we have the probability of A intersection B. We put this because multiply, this as the probability of A given B times the probability of B. So the probability of A intersection B is equal to this. This was given as half times this one was given as 2 on 9. Therefore, simplifying this gives us 1 on 9 as the probability of A intersection B. Then for Roman 2, we have the probability of A union B. To find this one, we apply what? The addition of probability. That is, the probability of A union B is the same as the probability of A plus the probability of B minus the probability of A intersection B. So we substitute the probability of A was given as 1 on 3 plus the probability of B was given as 2 on 9, and we just found this one to be 1 on 9. We take the LCM, it is 9. This goes here 3 times plus 2 minus 1. We simplify, we have this plus this is 5 minus this gives us 4 on 9. So the probability of A in B is 4 on 9. The next part, Roman 3, says that we define the probability of B given A. Just as we define this one, we define this one the same way. That is, the probability of B intersection A divided by the probability of A. This is the condition, that's why I'm doing like this. So, simplifying this is the same thing as what? The probability of A intersection B divided by the probability of A. I'm switching their positions because they make the same thing. And I'm doing so that we can easily see that we already had the result of this, and this one was equally given. So we just substitute and have the expected result. So this gives us the probability of B given A as this one, which was 1 on 9, divided by the probability of A, which is 1 on 3. Simplifying this, we have 1 on 9 times 3 on 1, which gives us 1 on 3. As the probability of B given A. Then the B part. The B part, during a Christmas party, a woman prepares 2 types of food, A and B. The food is kept in 2 dishes, large and small. 70% of the food is of type A. So that means that the probability of A is 70%, which of course is 70 on 100, or you can say it is 7 on 10. Anyone? And since we know that 70% was of type A, it means that 30% was of type B automatically. So the probability of type B is 30%, which also is 3 on 10. Now they were kept 30% of type A and 40% of type B were kept in small dishes. That is, if I let S be for small dish and L for large dish, it means that what? The probability of a small dish, given that it was of type A, is 30%, as the question says, that is 3 on 10, and the probability of a small dish, given that is of type B, is 40%, that is 4 on 10. The question now says, Roman 4. Find the probability that a dish chosen at random will be of small size. A dish chosen at random will be of small size. So we're saying that the probability of a small size dish is equal to what? It is either going to be a small size dish containing food of type A, or it's going to be a small size dish containing food of size type B. So we take the two. So we're saying that it is the probability of this or the probability of that. It gives us, we have this one. This one is 3 on 10 times this one was what? 7 on 10 plus this one. This one was 4 on 10 times this one was 3 on 10. We simplify all of this. This is 21 on 10 on 100 plus this is 12 on 100. We add those two fractions, it gives us 33 on 100 as the probability for a small digit to be chosen at random, or you can say it's 0.33%. Then the last part says that find the probability that a small size dish chosen at random will be only of type A. Will be only of type A. That means we are looking for the probability of A, given that it contains the dish, it's inside a small dish. And this is what the probability of A and S, all over the probability of a small dish. So simplifying this one, we don't have this result. So I'm going to write it as what? The probability of S given A than the probability of S, no, of A. This is divided by the probability of S. So this is 3 on 10 times 7 on 10 divided by this one, we calculated it to be 33 on 100. If we simplify this correctly, it should give us 21 on 33 as the expected probability. Question number 5A. What is a power function? Alright, let's define that. A power function is a single term function of this form. Let me write it so that you can see. You have a power function is a single term function of the form f of x equal to k x to the power r of this form, where that k and r are real numbers and x is a variable. That's the definition of a power function, meaning that it's a function having only one term. That's what I mean by single term. Only one term. And that term contains a variable raised to a power, and there is a coefficient like this. So the B part says, which of the following functions is a power function? Roman 1, f of x equal to 5 into x minus 3 to the power 4. Is this a power function? Of course not. By this definition of a power function, this is not a power function. This is a binomial. And if you expand this binomial, since the power is 4, you are going to have 5 terms. So, which means that it contradicts our definition, because for our definition, a function is power if it plus upon what? As just a single term. But this one has 5 terms, so it's not a single function, a power function rather. So The second one says that g of x is equal to 9 square root of x. Well, this one is a power function. I can write it as x 9 times x to the power half. This square root becomes the power half. And you can see that it satisfies the definition given above. That is, k in this case is 9, and our r in this case is this. So this is a power function. Then the C part. The C part says, given that f of x is equal to 100x squared and g of x is equal to x to the power 4, where x must be greater than 0. Find the values of x for which f of x is equal to g of x. Alright, for f of x is equal to g of x, it means now what? 100x squared is equal to x to the power 4. We take this one across, it gives us 0 is equal to x to the power 4 minus 100x squared, which I can turn it to have this, which is the same thing. That means just switching their positions. Because if this is equal to this, it means that this one is also equal to 0. So I just want to write it on the left. Now, to find the value of x, we can factorize out x squared. If we factorize out x squared, since it is common to here and common to this term also, this is going to give us x squared minus 100 is equal to 0. By the factorization principle, it is either this is 0 or this is 0. So if this is 0, it follows that what x is 0. Or if this one is 0, it follows that what x squared is equal to 100 by taking 100 across. And then we will now remove b squared by taking the square root of both sides. It gives us plus or minus the square root of 100, which gives us x as plus or minus 10. So the values of x are x equal to 0, negative 10, 10. But the question said x must be greater than 0. But since x is greater than 0 from the question, we have that the correct answer is x equal to 10. Like that. And then finally, D. Given that n combination 2 is equal to n combination 3, find the value of n. Well, by the definition of combination, this is what n factorial divided by n minus 2 factorial times 2 factorial. And it is equal to the same thing, n factorial divided by n minus 3 factorial, 3 factorial. So if we cross multiply, we see that it gives us n factorial into, or let me say n minus 2 factorial, 2 factorial is equal to n factorial, n minus 3 factorial, 3 factorial, which gives us, we can divide all through by n factorial. If we divide both sides by n factorial, you see that it cancels out, and we are left with n minus 2 factorial, 2 factorial, which is equal to n minus 3 factorial, 3 factorial. But 2 factorial is just 2. So we have it is 2 times n minus 2 factorial, which is equals to, and 3 factorial. 3 factorial is 3 times 2 times 1. 2 factorial is 2 times 1. So you see that 3 factorial is 6. So this is 6 into n minus 3 factorial. Our interest here is to find n. So to find this n, I'm going to expand this. We know that n factorial means n into n minus 1 factorial. So this implies that what? N minus 2 factorial. This is my n, I copy it. And then I now subtract 1, just like here. When you copy your n, the next value you subtract 1. So I'm going to subtract 1 here. I have n minus 2 minus 1 factorial. It is going to give me n minus 2 into n minus 3 factorial. So I am replacing this, I'm going to replace this by this. That is 2n minus 2 factorial is equal to 6 into n minus 3 factorial. Implies that 2. I replace this by this result. I have n minus 2, n minus 3 factorial, which is equal to 6 into n minus 3 factorial. You can see that this one can disappear on both sides, so that we now have 2 into n minus 2 is equal to 6, giving us, if we divide both sides by 2, we have n minus 2 is equal to 3. Seeing this one goes here 3 times. And so taking these 2 across gives us n as 1, 3 plus 2, or better still, n as 5, which finally completes the solution of this paper.